Yesterday we talked about how to find distance on a number line. We did the absolute value of the two coordinates subtracted. Yes, sir.
I forgot to go grab the calculator. Okay.
Yes, you can absolutely go grab a calculator. In fact, everybody's going to need a calculator today, so if you don't have a regular calculator, please go grab a yellow calculator off the cart there that is stacked super high with books. All right. So first thing I want you guys to get written down on your notes page, the distance formula. This is when we have ordered pairs, something on the XY axis. The distance formula is the square root, and then underneath our square root sign, we subtract the x parts of our coordinates, just like we're finding distance on a number line, just like we did yesterday where we subtracted the two numbers on our number line. My horizontal x's get subtracted, and then they get squared. And then we do the exact same thing with the y's. So we're going to label our points x1 and y1. And then the other point will be x2, y2. That is going to be the first thing that we do when we are finding distance between two ordered pairs. We're going to label up our points. Please keep in mind, and I say this only because this is a bad habit of mine that I get into, when I'm labeling my ordered pairs, my brain knows that every ordered pair starts with an x first, and then it has a y after the comma. But when I'm labeling my points, x1, y1, x2, y2, I get in the bad habit of putting two x's in one ordered pair and two y's in an ordered pair. Make sure that every ordered pair has an x and a y in it. All right. We're going to practice substituting into this formula and finding the distance between 2 points. So our first example here, we're going to find the distance on the coordinate plane between point J and point K. Just like yesterday, where it didn't matter which order we put the numbers in, which one was point 1 or point 2, which one came first or second, it doesn't matter here either, but we have to choose one of these to be my point 1 so that I know my x1 and my y1 go together, and my x2 and my y2 go together. Are you guys okay if we call point J our point 1, so that would be my x1, y1? x1, y1, and I'm going to label it. And then we'll do the same thing with point K, x2, y2. Now we're going to find our distance. I'm going to write my formula down first so that I make sure to substitute into it correctly. In my distance formula, we have this enormous square root sign. We're going to do x2 minus x1, and then we're going to square that. And then we'll do the same thing with the y's. y2 minus y1, and we're going to square that. Before we actually substitute in, I want to talk about some really important things. Yesterday, we said that distance could never be what type of number?
A negative.
Can never be a negative. I can't go for a negative 5-mile run after school today. Distance can never be a negative. If you ever get a negative when you're doing your distance, you've made a mistake somewhere. You need to go back and check and find your mistake. The way we force things to be positive is by squaring. And here's where your calculators will trick you if you're not careful, if you're not precise about how you put it into the calculator. What does it mean to square a number?
Double it. I mean, no, not double.
Not double it, but
multiply the number by itself.
multiply the number by itself. So 3 squared would be what?
9.
3 squared would be 9. So negative 3 squared, because you said it's taking a number times itself, right? Yeah. Negative 3 squared would be negative 3 times negative 3. What happens when I do a negative times a negative? It becomes a positive. So negative 3 squared would be what?
9.
Also 9. I want you to grab your yellow calculators for me real quick. The negative key is down on the bottom by the enter key. I want you to push the negative key, and then 3. And then I want you to hit the x squared button over here. So you should see negative 3 squared on your screen. And then hit enter and tell me what your calculator says.
Negative 9.
Is that what you guys just told me it was when we did negative 3 times negative 3, negative 3 squared? It should come out to be what kind of number?
9, just 9.
Should come out to be a positive 9, just 9. Your calculator lied to you. Your calculator is being really precise about order of operations, and it only knows what you type in, not what you mean. When you type in negative 3 squared like that without any parentheses at all, your calculator squares the 3 first, and then it sticks the negative sign on the front. It doesn't know that you want to do negative 3 times another negative 3. It thinks you want to do 3 squared and then make it negative. The way you fix this is by using the parentheses. So we're going to keep the parentheses as we're doing the problem, and you have to keep the parentheses when you put it into your calculator too. If you put parentheses around the negative 3 first, try it for me real quick. Open up the parentheses, then negative 3, close them, and then square it. And you should get a positive 9. The parentheses are super, super important when we are doing the distance formula. If you don't use the parentheses, you will get the wrong answer. All right, now let's practice substituting in. So point JK, or sorry, not point JK, segment JK. We're going to find this length or this distance. Open up some parentheses underneath my square root sign. What is x2? What's the first number I'm putting in? Negative 3. And then I have a minus. And what goes in for x1? 4. Negative 3 minus 4. Close my parentheses and square it. Plus, open up parentheses again. Now I want y2, which is negative 7 minus, and then we want y1. y1 is 3. Close my parentheses and square it. Now we have to simplify inside each of these sets of parentheses first. What is negative 3 minus 4? Negative 7. So I have negative 7 inside my first set of parentheses, squared, plus, and now we do negative 7 minus 3. What is negative 7 minus 3? Close. Negative 10. And if you said the negative and I just didn't hear it, I apologize. All right. If you put it in just like this into your calculator, just like this, including the parentheses, it will give you the right answer. I want you to put this into your yellow calculator. To get to the square root, because that's not one of the normal buttons on the calculator, to get to the square root, you have to hit the green second button first, and then you hit the x squared button. Super close, underneath the square root. So second and square root, then parentheses, negative 7, close your parentheses and square it. plus parentheses, negative 10, close your parentheses and square it. You're absolutely right. When you hit enter, what does it say?
About 12.21.
What's the very first thing you see when you hit the enter key? Is that the very first thing that you see? Is the 12.21? Square root of 149 is what it said on my calculator at first. This is what it showed me, which makes sense if I think about it, because what is negative 7 times negative 7? 49. What is negative 10 times negative 10? 49 plus 100 would give me 149. I don't know how big the square root of 149 is off the top of my head. I know it's bigger than 10, but I don't know exactly how big it is. I couldn't cut a piece of string that is square root of 149 inches long. To get it to show you the decimal, which several people have already done, before I make a mess here, to get it to show you the decimal, if it shows you a radical on your screen, a square root with a number underneath, you have to hit this back and forth arrow button right above the enter key. And when you hit the back and forth enter button, it will change it into its decimal form. And that comes out to be about 12.2. Let's take it out to a couple more decimal places. What comes after the 2?
1.
A 1 comes after the 2?
0.
0 and then 6. 5. 6, 5. So if I'm going to round this to 2 decimal places, 12.2065, if I wanted to take it out to the 3rd decimal place, I look at the 4th number right here. If that's a 5 or bigger, it makes this number go up to a 7. If it's a 4 or smaller, then it just stays the same. So I'm going to round this to 12.207.
You would also accept 2, 1, right?
I would accept 12.201, yes. You always want to take it out more than just 1 decimal place, 2 or 3 decimal places. Yes, sir.
Where do we get that?
On the yellow calculators. Did it give you this?
Yeah, I got that one.
Okay, so let's type that in and we'll start from there. Hit enter. Now hit the button right above enter. There you go. All right. Let's do part B. Let's try this again. So the first thing we need to start off with is our distance formula. So distance is equal to, and then we have a big, enormous square root sign. Inside parentheses, x2 minus x1. Close my parentheses and square it. Plus parentheses, y2 minus y1. Close my parentheses and square it. Let's make point A our x1, y1, so let's label that x1, y1. And let's make point B our x2, y2. x2, y2. And so now we're going to find the distance from A to B. So I replace the word distance with my line segment name, AB. I redraw my really big square root symbol, and I open up some parentheses. Now I want x2 to go in here. Which is my x2? 5. And then I bring my minus sign down, because minus is part of my formula. And then I need x1. What's my x1? Negative 6. So I need to put him inside parentheses. Close my parentheses and square it. Plus, open up parentheses. What's my y2? 9. Minus from my formula. And then what's y1? Negative 4. Close my parentheses and square it. What happens when we subtract a negative number? Becomes positive. So this is 5 plus 6 here. What is 5 plus 6? 11. So I have the square root of, still inside parentheses, 11 squared plus, and then over here I'm subtracting a negative again, so that turns into pluses because minus a negative is a plus. What is 9 plus 4? 13. So this is what I'm going to type into my calculator. Square root sign, so second to next squared. Inside parentheses, we're going to do 11 squared. And then plus, and then a new set of parentheses, and 13 squared. When you first hit enter on the calculator, it gives you something that's still underneath a square root. What's underneath the square root? 290. And then how do you get it to give you the decimal now that you have that? Press the arrows right above the enter key. We're going to press those back and forth arrows right there. But it's after you hit enter. It won't work before you hit enter. What does this come out to be? 17.029. Nicely done. Very nicely done. Yes.
Is this the right way how to type it in?
Yes. Yep, and then hit enter. Oh, what's happening here? Grab one of my yellow ones for right now. I'll play with that one and I'll be able to tell you exactly how to type it in on that one, but grab a yellow one just for right now.
When you're dealing with positive numbers, do you have to put in the parentheses
When you're putting it in the calculator, we're going to see a couple examples where, yes, it does make a difference. On these two, on the first one, it definitely makes a difference. If you don't have the parentheses, it's going to give you the wrong answer. On the second one, if you didn't have them, it wouldn't change your answer, but on most of the problems, it will change your answer. So we always want to err on the side of putting that in. Oh, let me grab you another one then. Sorry, because that one works different. Yep. There you go. Yep, that's okay. Okay. All right. I will figure out exactly how to put it in there for you, okay? You're welcome. Okay. Let's look at some story problems using distance formula. Chelsea and Amy are sitting in separate cars on the Monongahela incline. No idea. Chelsea is traveling up Mount Washington and Amy is traveling down. When the two girls notice each other, Chelsea has a horizontal distance of 212 feet from the lower station and is at a height of 151.6 feet. Amy has a horizontal distance of 435 feet from the lower station and is at a height of 311.3 feet. What is the distance between the two girls? So they've given us two ordered pairs. It doesn't necessarily look like it, but they've given us two numbers for each girl. So I have an X and a Y for each girl. So let's do Chelsea. I'm going to call Chelsea point C. Does the X-axis go up and down or back and forth? Back and forth. Would we call that vertical or horizontal? Horizontal. So when it says horizontal distance, they're giving me my X right there. 212.0 is my X. We're going to call this our X1. And then the y goes up and down, and that would be which number? 151.6, the height. 151.6. So there's my y1. So I have my x1 and my y1 for Chelsea. And then we have Amy. What's Amy's x? What's her horizontal? 435.3. There's my x2. And then what is Amy's y? 311.3. There's my y2. These numbers are very big, and that's okay. So my distance formula big square root sign, parentheses, x2 minus x1, close them and square it, plus y2 minus y1, close it and square it. So we're going to find the distance from C to A. Need a really enormous square root sign for this, because my x2 is 435.3 minus my x1, which is 212. And then I'm going to close the parentheses and square that. Plus y2, 311.3, minus y1, 151.6. Bless you.
Thank you.
Close my parentheses and square it. All right. We need to do 2 subtraction problems, and then we can pop this into our calculator. What do you get when you do 435 minus 212? I'm sorry, how much? 241? I got 223.3, and if I misheard, I apologize. I got 223.3. Can somebody double check me and make sure they got the same thing? Because it's possible that I did something wrong. Is that right? Okay. Plus, now we got to do the same thing with the y's. What is 311.3 minus 151.6?
Wait, why would Amy's height be positive if Amy's going down the mountain?
Because she's still above this lower station. That's a really good question. They're giving us their location from the lower station, so from something at the base of this mountain. They're heading down, but they're not down yet, so they're still above it.
Okay.
Does that make sense?
Yes.
Okay. All right, I apologize. The y's, when we subtract them, we get 159.7. Close my parentheses and square it. At this point right here, I can put this into my calculator. If your calculator just spits out a decimal at this point, that's great. If it gives you something with the square root over it still, you know you need to hit that button right above the enter key. So I want you to put this into your calculators.
Some of the buttons are not seeable, so
Oh, joy.
that one you have the parentheses. It's a green button when we do
The square root, yes. You have to hit the green button, and then you hit this button afterwards. Do you see how there's a square root button in green right there? That's why you hit the green button, and then you hit this key. Okay?
Oh.
figured out how to do it on your calculator. Go ahead and finish this problem on that one, and then when we get down here, I'll show you how to do it on yours.
Okay. 383.
Got something smaller than that. Are you guys getting something bigger or smaller than 500? Bigger or smaller than 200?
Bigger.
Bigger than 200, smaller than 500. Bigger or smaller than 300? Smaller, so it should be in between 200 and 300. I got 274.53 when I took it out to 2 decimal places. I got 274.53. If you guys are having trouble getting the same final answer as me, please let me know because I want to help you put this into the calculator so that you can get the correct final answer. What'd you say, dear?
I need help.
With putting that one in?
Yeah, I didn't get the answer.
Okay. So second, and that, parentheses, 223.3. Nope. There you go. Close your parentheses and then hit the x squared button. Plus, parentheses, 159.7. Close your parentheses and square it. Hit enter. There you go. You got a question? Okay, so you start with the green second button, and then you push the x squared key. So that's how you get the square root to show up on the screen. Yep. And then it's parentheses and your numbers from there. All right. Still not getting it? Because you have 2 separate square roots. It's all underneath. Notice it's one big square root sign with these things being plussed together under it. So if you clear it out and then you hit second so that you get the square root up there. There you go. So second and square root, and then parentheses. Close your parentheses and square it, and then hit plus right there. Yep, and then keep going. And that should give you the right answer. Let's look at number 5. It says Manuel wants to go snowboarding with his friend. The closest ski and snowboarding resort is approximately 20 miles west and 50 miles north of his house. I'm going to draw a real quick XY axis here so that I can kind of see what's going on, what they're describing to me. Okay, so right in the center is Manuel's house. If I'm talking north, south, east, and west, what's up at the top? North. Bottom? South. What about over here on the right-hand side? East. And so west would have to be on the left-hand side. So let's figure out where this ski resort is. The ski resort is approximately 20 miles west and 50 miles north of his house. So it's going to be somewhere over here, right? Since I'm not being asked to plot the point, I don't need to be precise. I just need to know that it's over here somewhere. 20 miles west and 50 miles north. Well, if I go this way on the x-axis, are my numbers positive or negative? Negative. So negative 20 for my x1 because it's 20 miles west. And then 50 miles north. If I go this way, are my y's positive or negative? Positive. So negative 20 and 50 would be my coordinates for the ski resort. And then his friend. Manuel picks up his friend who lives 15 miles south and 10 miles east of Manuel's house. 50 miles south and 10 miles east. Is that going to put me in quadrant 1, quadrant 2, quadrant 3, or quadrant 4? Quadrant 4. South and east is going to be over here somewhere. And what should that ordered pair be then?
No, 10, negative 15.
10 and negative 15. Why did I not put the negative 15 first? That was the first number they gave me.
Because south is the y-axis in this case.
Yes, this is our y-axis. So north and south numbers have to come second. So 10 and negative 15. X2, Y2. How far away are the two boys, because Manuel went to pick up his friend, how far away are they from the ski resort? So we want to find the distance from the friend. Friend is 10, negative 15 from the ski resort. So I'm going to call that point S. That's going to be my X1, Y1. It does not matter which one we call X1, Y1, which one we call X2, Y2. I could have called the friend's house point 1 instead of point 2. Does not matter. So distance is equal to big enormous square root sign, X2 minus X1 squared plus Y2 minus Y1 squared. So we're going to find the point, or the distance, sorry, from friend to ski. What's my X2 that I should put in here? 10. So 10 minus
20. Negative 20.
10 minus negative 20. Be careful there. The minus came from the formula, but the second number is a negative 20. Close my parentheses and square it. And then plus, and now I need Y2,
Negative 15.
negative 15, minus Y1, 50. Close my parentheses and square it. You guys already answered this for me once. What happens when I subtract a negative like this? Becomes a positive. So I have 10 plus 20, which is 30. So I have underneath my square root sign, I have 30 squared plus, what's negative 15 minus 50?
Negative 65.
Negative 65. So 30 squared plus negative 65 squared. Go ahead and pop that into your calculator and tell me what it says. I'll be right there.
This is
Yep, that's what I got.
one more thing. Under the slide, I noticed that like the equal signs you do this. Does that mean something?
It means about or approximately. It means I had to round my answer. If you keep using the equal sign, that's perfectly fine. But whenever we've had to round, I usually put those squiggles to show that we had to do some rounding.
71.58.
Yes. All right. I've seen a couple people's answers. Everybody looks like they're doing good so far with the ones I've seen. I got 71.589. Should we put units with, if you only took it out to 2 decimal places, that's fine. Should we put units with that?
Yes.
What should we put?
Miles.
Miles. Technically, I probably should have put units with my problem before. What units should I have used on number 4? Feet. All right. Let's flip it over to page 11. There's one thing up at the very top. first thing we're going to do is write down our two distance formulas. If I'm just going between two values on a number line, the way we find the distance is the absolute value of x2 minus x1. You just minus your x's and make it positive. Doing distance with points that are xy, that's when we have to do our big long square root sign one. x2 minus x1 squared plus y2 minus y1 squared. All right, last problem for today. You are given that C is the midpoint of A and B. So I don't know exactly what this line segment looks like, but it tells me that C is the midpoint in between points A and B. What do midpoints do to line segments?
They cut them in half.
They cut them exactly in half. They're the exact middle point. So if I take this line segment and I cut it in half right here, what does that mean about these two small line segments now? Yep, they're the same distance. They're congruent. So this is the same size as this. Says that my point A is negative 5, 3. I'm going to call that my x1, y1. And then point B is 2, negative 8, x2, y2. And I know my line segment doesn't match up with the way this would look on an actual xy axis. I didn't plot my points in the right spot because I drew my line segment before I knew where my points belonged. I just drew a picture for me to kind of understand what's going on here and what that midpoint was. I know it's not exact. All right, let's find our distance. It says find the length of AB, and then we're going to have to come back and find this next, but we're going to find the length of AB first. So distance is equal to big long square root parentheses x2 minus x1 close parentheses and squared plus y2 minus y1 close parentheses and squared. So let's find the length from A to B first. What's the number that goes with x2?
2.
2. And then minus from my formula. And now I need x1.
Negative 5.
-5. So 2 minus -5. Close my parentheses and square it. Plus, and now I need y2. -8 minus y1, 3. Close my parentheses and square it. Whenever I subtract a negative like this, it turns into pluses. So that is 2 plus 5, which is what? 7. So inside parentheses, I have 7 squared plus, what goes in the other parentheses? -11. And so now this is what I pop into my calculator. Before you hit the back and forth arrows, does it give you a radical or a decimal? Radical what? 170. And so then you change it into its decimal form, and that's about how big? 13.038. All right, that's the first thing they wanted me to find. So I know the length from here over to here is 13.038. But then they also wanted me to find the length of BC. I want just this much right now. Well, these two are the same size. Divide it by 2. We're going to cut it in half because this is half of the whole line segment. So for BC, we're going to take 13.038 and cut it in half. Divide it by 2. And what do we get when we do that? 6.52 or 6.519, depending on how you rounded that. Yes. All right, real quick before I read the announcements, I had a really good question earlier about why I'm using these squiggles instead of the equal sign. I do not expect you to do this. I won't take off points if you don't do this. But the squiggles mean about or approximately. It means I had to round my answer. This is what the calculator said, and that was everything on the screen when I hit enter. So it's equal to that. But then when I hit those back and forth arrows and it changed it into a decimal, I didn't write down all the numbers on the screen, did I? Since I didn't write down all the numbers on the screen, I used that squiggly to mean about or approximately. Don't forget, your homework is due on Monday. Most of the problems are focused on what we did yesterday, finding the distance on a number line. The stuff that we did today is problems 22, 23, 32, 36, and 40. These are the ones where you have to use that big, long square root formula.